think 5 more minutes, then I'll get started. Let's wait for everyone to join.
Yes, ma'am. Yes, ma'am. Yeah,
Thank
we
you.
got you now.
You can see my screen here. Anyone, please?
Yes,
Can
ma'am.
Yes, ma'am.
Okay, thank you. So you can
Good
see
evening to
PPT. You can see. Uh,
Yes, ma'am.
you can see that, right? Okay,
Yes, ma'am.
great.
good evening to all. I am honored to extend a warm welcome to our distinguished resource person, our respected head of the department, and all the
Hello? Hello? I think I lost.
Okay, so
good evening to all. I am honored to extend a warm welcome to our distinguished resource person, our respected head of the department, and all the brilliant minds joining us for this 6-day online faculty development program on generative AI in Shaping Industry 6.0. On behalf of our Department of Computer Applications, Konga Art and Science College is delighted to welcome all the participants from various institutions to attend the AICT Training and Learning Academy. It's my honor to invite our eminent resource person, Ms. Swati Ravishankar Bhatt, AI Architect, Caterpillar Incorporate, Bangalore, to deliver the session address. It gives me great pleasure to introduce the eminent resource person joining us today. She is a seasoned IT professional with 14 years of experience across banking, finance, healthcare, automobile, pharma, and oil and gas domains. Currently working as a Gen AI architect, she had led multiple successful use cases from idea to implementation. She has previously worked with TCS, IBM, and Shell, delivering impactful solutions traveled across global markets, including the US, Japan, and Europe. She specialized in applying generative AI to real world problems, deriving innovation and business transformation. As a passionate mentor, she actively guides teams in emerging AI technologies. With her vast knowledge and expertise, we are sure that the session will be enriching and insightful. Ma'am, we warmly welcome you to share your thoughts on the ML Gen AI synergy. Welcome you, ma'am. Now the session is yours, ma'am.
Thank you. Thanks a lot, everyone. Good evening, everyone. My respected deans, our amazing faculty, and of course, my all dear students. That's why I'm here for. First of all, I'm truly grateful for this wonderful opportunity provided to me. I would say it's an honor for me to be here. Not just an honor because it has always been my childhood dream to because when I was in college as a student, I always used to see people coming to our college, being a public speaker. So I always thought one day I could be the one, and this gives me an immense pleasure to be here, personally as well as professionally. And also, I would like to thank Congo Arts and Science College faculty, the head of the department, Sangeeta ma'am, then Rutra ma'am, for approaching me and making this happen. Definitely, it's a honor again. Thanks a lot for everything. And also, it's also an honor be here because it is also a reminder for the exciting times we are in, right? So we are living in a Gen AI world. So today's my topic would be machine learning, Gen AI synergy, right? So welcome to everyone again. This would be my the third session. I'm presuming it's my third session in this Gen AI shaping uh, 6.0. So let's get started. So before uh, starting a little bit of myself, I have total 13, yeah, almost 14 years experience in IT. So I started my career with an SAP consultant. So I worked in SAP for almost 7 to 8 years. Then I worked throughout my career on data analytics platform, mainly on the data architecture side. And also I got opportunity to travel to various countries on various work assignments. I'm truly grateful for that. and I explored a lot of cloud architecture as well, like Azure, AWS, GCP, Databricks, Snowflake. So as part of my work assignments. So this is bit about my career. Currently, I am working as a GenAI architect in Caterpillar, and primarily I am handling GenAI implementations mainly on the vector database side, because that is more because of the unstructured data where we would be storing them. So vector database is I think the new kid in the town, I would say, and currently I'm working in that area. So coming to the past roles, I worked as a data engineer. That's how I started my career with. Then I worked as a technical lead, then data architect. Before becoming an architect, I also worked as an AI engineer as well. So this is pretty much about myself. Uh, Coming to my personal life, yes, I am married. I have a 4-year-old son. I live in Bangalore, and I'm basically from Karnataka. So I spent most of my childhood in Shimoga. So it is a place in Malnad where I did my studies, my post graduation, and all I did in Bangalore. And I would say I pretty much am settled in Bangalore, uh, and I've been fortunate for that. So I think with that, let me get started. So as I said, uh, let's first take you through about what I will be covering as part of this session. So my topic is machine learning Gen AI synergy, right? I think in the previous sessions you already have got a little glimpse of what machine learning is about, right? So here I would be going a little bit deep about what machine learning is about, how it is originated, and how many types of machine learnings are there, and what are the real life use cases where we are been working on, and how it has been helpful to us, and how it has been evolving. So let's my first topic will be around the journey of machine learning, mostly how it is originated, okay, till now. Then I would be so this is I don't want to make this session more technical, because uh, using a lot of technical jargons may confuse people, and sometimes it may go above the head. I understand it is kind of a complicated topic, so I would like to try to make this as simple as possible by using a lot of analogy, relatable terms, relatable stories. Okay, I would like to start with a story. Then I would be jumping into more on the stages of machine learning, right? How, what are the different stages, a life cycle, I would say, for a machine learning. Then I would be diving into the types of machine learning. What are the types? We have several types here, right? So then I would be covering about the model drift, right? The model drift and monitoring. Then I suppose when machine learning what happens if there is a drift in the model, right? If machine model is not working as expected, and at the same time when we're building a model, we have to monitor it as well, right? So that is also I'm going to cover here. Then the most important topic, which is data bias, right? And the importance of data quality, how important data is, because if we are not feeding the model the proper data, our output would be not appropriate, right? That I'm going to cover here. Excuse me. Then very important, data governance, because we cannot let the data or the model play around in its own way. There has to be separate proper boundaries we have to set, right? Governance, some of the governance principles we have to set. So that I'm going to cover. At the end, I'm going to conclude with machine learning, how it is different from Gen AI, and how they are working and in tandem with each other, right? And how when they are together, that's what my topic is about. When there synergies are there between machine learning and Gen AI, how it is doing magic. I'm going to conclude with that, and at the end we have a Q&A session. So in between if you have any questions, please park it, and we can have all the questions answered in the end of the sessions. So let's start with that. Let's get started. So so I would like to tell you, so just look at the world around us. So how it is changing? It is changing constantly. What was yesterday is not today, right? It is constantly evolving. For example, Gen AI, for example, it is evolving, right? Evolving in the speed of lightning speed. And we started with chatbots in 2021 when ChatGPT released its own Gen AI model. We started with chatbots. Then we got all our questions answered. Now and now we have AI that can create, right? It can create, it can reason, and even it can act like independent agents. We are in the era of agentic AI now, which is helping us. It is more like an assistant to us, more like a friend to us, which can help us write code, then help us write story, then design something. If we have helping us even do the project assignments, the college assignments also, right? I'm sure everybody has used it for everything. The students, it's super helpful for students, for everyone, for research scholars, you name it, everybody, right? And in some case it's also helping us even shop, do the shopping, okay, or the may all help us take the important decisions of our life. So it is more like a companion, I would say, to us it has become. So how it all started? It all started with an experimentation, right? What started with an experimentation is slowly becoming part of our daily life, part of our daily routine. And it's not just that, it is shaping the way we learn, we work, and how we are innovating. And this is exactly the topic of this uh, topic today, right? Gen AI, how it is shaping the industry 6.0. So let's see, let's dive into how Gen AI is helping us shape this, and why it matters, right? Why this moment particular matters? Because as students, as research scholars yourself, and as future leaders, right, we are not just watching this evolution, right? We are also becoming a part of it, right? So with that, let's again start with the journey, as I mentioned. Okay, journey of this machine learning is very interesting. Okay, so we must be thinking AI came around in 2020s, right? But that's not true. So AI is there from 2000, sorry, and from 1950s itself, from 1940s itself. It is not a new town, this boy in the market. So to start with the journey, I'm going to explain with the small analogy here, right? Let's start with the childhood, right? So imagine machine learning as a young child, a child who is growing up into a genius. So let me take you to this story. So childhood, I would say it is like 1940s to 1950s, and I would call it as a birth of an idea, right? Because in 1940s scientists thought, hey, what if the machines could think like humans, right? Because even back then people were thinking about of making machines do things what humans are doing, right? It is even back then. So there were two scientists called Mikulich and Pitts. So these are the two scientists who first created something called artificial neuron. Okay, we are all aware about what neurons, right, in our body, right? So neurons are somebody who are responsible for everything we do, what we eat, what we drink, what we breathe. Pretty much everything is because of the neurons in our brain, right? Similarly, these scientists thought, first let us invent something called as artificial neuron, which is exactly like building Lego blocks, right? I think everybody has played with that Lego blocks for the brain, like for in other words emulating the same thing which our human brain could do. So that is how the idea was originated. And in 1952 there was another scientist called Arthur Samuel. He made a computer, something like playing checkers and learning from his mistakes. So that is how it was originated. It was more like imagine teaching a toddler, right? A toddler of around 4-year old. So he's learning to ride a bicycle. So first when he tries to ride a bicycle he will be just going little wobbly, right? uh, when he's just learning. So slowly he's trying to learn step by step. That child is learning step. So that is the era of childhood here. So next comes the teenage years. So I would say it is 1960s to 1970s. I would call this era as a era of high hopes but harsh reality. I will tell you why. Because 1960s started with full excitement because they already have had a history, in childhood. They already scientists who had discovered this artificial neuron, and it started with a lot of excitement because there was something called perceptron, and that was invented. Perceptron is nothing but the brain inspired machine. Think of it like a brain inspired machine. So everybody thought machines would be soon be smart as humans, right? Even back then, but that's not true. Okay, reality hit very hard. Reason being, just like teenagers, right, who are in their teens, they realize that life is little tougher than they were in high school, right? They realize that. Similarly, the computers realized that they couldn't solve these hard real world problems. They're only able to solve the basic ones. So that was quite challenging for them. At the same time, there was little funding also, which was kind of dried up. So I would call it as a AI winter, right? 1960s, even though it started with excitement, it didn't reach where it had to reach. Then slowly adulthood begins. I would say it is around 1980s to 1990s. I would call it as an era of smarter tools. So what happened here? So in 1980s, scientists found a new trick called as back propagation. So what is back propagation? It is like machines could go back and correct themselves. So that is what propagation means. And at the same time, some other models called like decision trees, SVMs, Bayesian models all got originated. They're nothing but a calculators, pretty much, and a toolbox of machine learning, I would say. But the real thing came in 1997, right? I think people who are in 1997, in that period, they would have read this news. This IBM came up with something called Deep Blue. Okay, this Deep Blue was able to beat the world chess champion of that time, Gary Kasparov. So Gary Kasparov was the world chess champion, and this computer, okay, IBM's Deep Blue was able to defeat him. So that was very big news that time. It came in all newspapers. That is when it was kind of a wow factor. Okay, people were kind of thinking, oh, something like this computer can do these things, they can play a chess like humans. That was the error. So I would say this adulthood is more like a machines entering adulthood. So they are not perfect. They are little bit groomed now, not like teenage or childhood. They're not perfect, but they're starting to beat humans now, at least, right? That's an improvement compared to the earlier eras. Now comes the real boom, I would say, 2000s to 2010. So I would call it as big data, big boom. So because this is the time when internet came into picture, right? So as soon as internet came, suddenly we had oceans of data, right? We had at the same time we also had GPUs, which gave a muscle, I would say, to the machine learning models. And in 2012, a person called AlexNet, he crushed the ImageNet challenge, and he discovered something that recognizing images, uh, it was able to do better than humans. They're able to recognize images far better than humans. So I would say this era is like machine learning getting a kind of a superpower, a kind of a upgrade, right? Suddenly it was not like a nerd like it used to be before, but now it has become like a more like an athlete with the brains and bronze. Then comes the rock star era, right? Which are we are currently. I would call it as a generative AI. So then when generative AI takes over. So today we are live in the world of transformers, right? So transformers means don't imagine the the Matrix what we watched in the movies. Not the robots from the movies, but the algorithms, I would say, like GPTs or Birth, the transformer models. So these models are not just recognizing the patterns, but they are also able to create something, like create stories, create art, create music, right? Or build a code. So now machine learning has grew into a rock star, I would say, right? It's able to do pretty much everything what I just said, and it's also able to chat with us like our friend, right? So if you see this journey, all in all, what I would say is the journey of machine learning is like a learning like a human life. I started with the childhood, right? From how a curious child in 1950s, and it went through a lot of teenage struggles. In adulthood also it faced lot of difficulties, right? But it earned a lot of skills, and now it has become a superstar. It's like a journey, like a person, right? I would say, and now it is shaping the world. And what is the exciting part about this is this story is not over. It still is going to, things are going to evolve, because what, as I said, what was yesterday is not today, and what is today is not tomorrow, right? So I would say you are the next chapter, the students here. So I we covered pretty much about the interesting story of machine learning, and now let me start with a small introduction. So let me take you back.
நல்லா இருக்கு சாமி நீங்க இப்படி இருக்கிற பார்த்து
Sorry. Okay, let me take you back to a time very not long ago, just a few decades back. I think everybody of us can resonate with that. Imagine our grandmothers, our mothers. Did they have any YouTube videos or YouTube cooking videos or any food blogs to cook their recipes? No, right? So, the same way, this boy here, so he's watching his grandma in the kitchen. So, he's realizing she had no recipes, okay? She has no measurements, she has no timers or some like we have now. And but yet her food turned out to be perfect every single time, right? So, the boy had the question in his mind, how? He asked the grandma. I think the same questions even our we had, because our mothers, I don't remember using any YouTube videos anything to cook their foods, but they even didn't had even measurements. But their recipes used to be amazing, right? Even now. So she just had a smile on her face for the boy's questions, but the real answer to this question is she had learned it from the patterns, right? Because she's doing that every day, right? The sizzle of the oil told her the right moment to add spices, the tadka, what we call, right? When to add the uh, mustard, right? When this aroma comes, add the next ingredient. It is just everything on the top of her mind. She has not learned it by seeing any book or any video. The smell in the air told her that, okay, the dish is done. Okay, this aroma is coming. Okay, my dish is done. So no one taught her that explicitly, right? To our grandmothers. She just learned by doing, by observing, and by improving. So just like that, just like her, our machines today are learning by observing the patterns in the data, by improving with the each iterations, and making every decision better, better over time. And that's the journey we are able to explore today, right? Let's move on to the stages of machine learning. So yeah, this is the stages of machine learning. So I would not going to, as I said, I'm trying to put this as simple as possible. I'm hoping everybody is following me, right? If I'm going too fast or too slow, please let me know. uh, the stages of machine learning. Okay, I would like to talk about these stages with a doctor's perspective. I think let me break down how this machine learning model, right, how it actually learns, not with big project life cycle, but the real gritty stages this model goes through. Okay, how it becomes smart, right? Let's go step by step. and to make it stick, I'm going to use this doctor's example. How a doctor learns to diagnose disease, right? Imagine this doctor has freshly or what how he treated patients. He's using his experience here, right? So first comes the data collection. So before anything starts, right, what we need data, right? That is the heart and soul of the model. Imagine you're training a new doctor. Okay, so you have put together hundreds, maybe thousands of patients file. You have a piled up big patient file, and you're keeping in front of the junior doctor here. Okay, so each file, it contains? It contains the symptoms, it contains the test results, and it contains the demographics, right? And most importantly, it contains the actual diagnosis of the patient. And this becomes your training data sets. Okay, using this data, you using this for training. Okay, and without this, the doctor has no experience here, right?
Ma'am,
Sorry.
ma'am, our screen is stopped.
Sorry, my screen is.
Ma'am, your screen is stopped. Not being.
You're not able to see the screen.
Yes, ma'am.
Yes, we can see the screen, ma'am, but first screen is only available. First slide is visible.
Okay. You are not seeing the stages of machine learning screen?
The
No,
screen is
no,
not.
no.
Okay. Not
Ma'am,
sure why.
kindly share screen again.
Okay, okay. Let me share screen again. Mm, you can see the screens now, ma'am?
Yes, ma'am. Yes.
You can see, right? Okay. And the display settings, let me swap. Okay. Now it is fine.
It's right, ma'am. Okay.
Okay. Excuse my. So this would becomes the training data set, right? Uh, Now, without that, the model has nothing to do. So this data collection becomes the primary step here, collecting the data. So now comes the data pre-processing. So what is data pre-processing? So let me be honest. The real world medical data is messy, right? When data comes to you, it comes in different formats. It comes in structured format, sometimes in unstructured format. Suppose think the patients doesn't get their blood test done, right? Or something thing as the weight is in pounds, it is not in kgs, for example. And imagine that the records are not complete. Some things are in the form of scanned documents, some are in pdfs, for example. It is completely scattered here and there. So what is our responsibility? We have to do the pre-processing, that means data cleaning, right? So what we do here, we will fill the missing values. For example, there is a blank column, we make it as zero there, right? Or for example, there is a format which are different, 4 5 formats, we have to make it a single format. And suppose there are some noise, for example, we have to remove the noise in case if there are audio files or something. And you have to categorize them, the categorize this file into this patient category or something. So this way we are processing or cleaning the data. So once you getting everything into clean, you are getting that into structured data, right? Because models also, you cannot feed the data models just something out of what you got, right? You have to because it is learning, right? When you're giving, for example, you're giving a child something to learn, you have to give it in a proper format, proper column, right, for it to learn for better clarity. So that is what we are doing in pre-processing. Then comes the feature engineering. Okay, feature engineering is nothing but suppose how much ever doctor great he is, okay, uh, he has to interpret it also. For example, mm, a feature engineering is nothing but, for example, there are two features, for example, okay, for example, high bmi, and there is one more feature called as elevated sugar. So what happens if a patient has a high bmi plus elevated sugar? Then there is a metabolic risk, right? That is what the doctor has to interpret. It's like it's not given something to you based on something, you have to interpret something, you have to come up with a new feature. So here the doctor is creating a new feature here called as risk score. So based on the vitals and the BMI, he's coming up with a risk score. It could be maybe uh, out of 10 would be 7 or maybe 8, right? So this is a new feature engineering he is doing. He's like bringing up a new features or a new column here. So I can give an example like a flag maybe, right? Suppose his sugar level is some 180 or 200, maybe he comes under the medium category or a high sugar category, something like that. It's a flagging or a grouping custom the patients into proper formats. So that is feature engineering. Then comes the model training. This is the very important part, right? Suppose eventually this is what we are doing with, we gather data, we clean the data, then we added some new columns here. Now it is the time to train the model. Okay, the training the model is similar like a training a child or a training a students. Um Now the doctor is learning here in the model training, right? He's going through hundreds of files, hundreds of symptoms. He's analyzing, okay, this means, okay, this could be diagnosis, could be this, right? He's trying to make use this sense of it. uh, and here our machine learning model is also doing the same thing. He's getting creating more input features, and he's creating labels here. And as we are in the model training part, let me take through in deep here, a little bit deep. Okay, we will see the rest of the things later. Let's dive into the types of machine learning. Okay, I will again come back to that slide later. So, supervised machine learning. Okay, let's talk about the commonly type of. This is the most commonly used type of machine learning, I would say, supervised machine learning. Okay, so why it is called supervised machine learning? Imagine you are teaching a child or a student, okay, to recognize fruits. For example, I would in the picture you can see the boy. It's a child, so the parent is showing him a banana, a image of an apple. Okay. And next image is showing him the image of a banana. Okay. And he's doing that over and over again. He's showing them the orange. Then slowly the child starts to learn from these labeled examples, right? So that is exactly what supervised machine learning in a nutshell. So we give the model. So here what machine learning, supervised machine learning is about is, we are giving a model a data sets for which we are telling the question to it, and we are also we telling the answer also to it. So all it has to do is grasp it. Okay, learn what is been told to him. Just listen and make sense of it and learn from it. That is what supervised machine learning, because here we are supervising the learning of the model, right? You're giving them the question and answers too, right? Both the inputs, for example, input here is apple. Input here you're showing him like a round shaped fruit which is red in color. That is the input. Output is apple, right? And here for banana, input is a curved shape yellow in colored fruit. Output is banana, right? So inputs and outputs are being given to the child. So what we are doing in supervised machine learning, right? We are essentially teaching a model uh, to predict something based on the labeled data, what I just told. But then again, we have two types of supervised machine learning. One is classification and one is regression. So classification I just already mentioned, right? It is about answering the question which category it belongs to. For example, you're holding a fruit. Okay, it's red in color, it's round in shape, and it is about 150 grams in size, in grams. Now the model says, hey, it's an apple, right? You gave all the inputs to it, it's an apple. Now comes the classification. Classification is about putting things into bucket. For example, you gave the apple, banana, orange. We use classification model to classify it into certain categories, right? You have for example, foods, vegetables, everything. Then the child will categorize apple means it's a fruit, brinjal means it is a vegetable, like that. In real life, we have scenarios like, for example, in Gmail, right? In Gmail, when you receive an email, Gmail has a feature of categorizing the email into spam, into important, into primary. I think all you have seen. So that is machine learning behind it, right? So it is categorizing the email whether it is a spam or not. Suppose if you having a lot of advertisements in the email, it identifies that it is a marketing email. It is not an primary email, and it goes and puts them into the spam or the that category. And suppose in the medical science, whether it's a tumor, there's a tumor, okay, you're feeding a picture of a tumor to the model. It tells whether it has been malignant or been benign. Malignant or benign means whether it is dangerous or whether it's non-dangerous tumor. Okay, so goal here of here is majorly the maximizing the classification accuracy, right? Model should not do any wrong in classifying the objects or the images. So there are often certain measures to calculate it. For example, precision, fun score. These are some of the parameters using which you can validate whether the model is working as per expectations or not. Then comes the regression. So regression is doing something different here. So in classification, what it is doing, it is telling whether it's an apple, banana, or whether it's classifying whether email as a spam or a non-spam, right? But regression, it is telling you what value it should be. Suppose you are showing an image of an apple, okay, um, instead of telling how much does it is telling how much does it cost. Okay, this apple, it cost maybe 40 rupees or something, right? And for example, if you're feeding the model, for example, the a plot, maybe a plot is 60/40, it is in so and so location, and what could be the cost price of that plot, and it will tell you so and so amount. It's about the amount. Okay, it is giving you the value here in numerical value. But in classification, it's just classifying or categorizing here. Or whether weather forecast, based, or whether in the uh, forecasting the stock prices. For example, last year's stock price, if you feed and you tell the model to predict the next month's stock price, something like that. Okay, so here the main goal in regression is it is minimizing the errors in the numerical predictions. Obviously, model cannot tell you the exact price, right? Definitely not. It is not possible to give the exact price of any but definitely it can give you somewhere near closer price for a particular thing what you. So that is what the purpose of the regression is actually. And there are certain measures here as well, like mean root square error and RMS, R square score. So these are something which are trying to parameters trying to measure whether the model is working as expected or not. So in summary, what I would like to tell is the classification helps us decide what something is, okay, and the regression helps us to estimate, okay, on how much the price it costs. So that is about supervised machine learning. Okay, now let's go back to unsupervised machine learning is about. Okay, if you see this image, you can see here, right? So when modern, this is something where model learns without any supervision. The name as suggests, like unsupervised machine learning. So here we are not uh, spoon feeding him or the model. We are letting it figure it out on its own. Okay, that is the difference here. We are putting here all the raw data, as you see, can see in the picture. The balls with different colors are being put, and it's automatically doing the clustering, right? You can see it is segregating itself into orange, green, and blue. We are not teaching it; it is doing all by itself. I will give you an example here. Imagine you are walking into a room, okay, room full of people you don't know. Okay, you are going for the first time, and you have don't know any name tags or don't know any people over there, no background information, nothing. But pretty soon you start noticing things. Okay, some people are gathered around the coffee machine. You can you imagine, okay, probably they are caffeine lovers, right? Then some people are talking about the technology. Maybe you soon start finding maybe they are engineers. Okay, and there are certain group of people who are talking about the research papers, uh, or maybe talking about the college principal universities. They might be professors, right, or the research scholars. So there's another group of people who are already on the dance floor. Already they are dancing, having a nice time. So clearly they would be extroverts, right? So your mind is doing, putting them, categorizing it automatically, okay, without doing any efforts, right? It's your brain is doing automatically. That is exactly what unsupervised machine learning is about. So your brain is naturally finding patterns here. Okay, it's grouping people based on the behaviors or the similarities it can find. So as I said, it is grouping about, and it is used in market segmentation, anomaly detection, in the crime, right, in the how it is able to detect. For in bank, a lot of frauds happen, it is used there. Identifying by if there is an anomaly. Okay, suppose there is a back statement, there is, if there is any suspicious activity happening, it automatically detects. That is where unsupervised machine learning is being used. Now comes the very interesting part, reinforcement learning. Okay, so it is one of the most fascinating one, I would say. Why is because if supervised machine learning is about learning with a teacher, okay, unsupervised is like learning without any instructions. Here reinforcement learning is like learning with experience, learning with trial and error. For example, all our years we have lived, we might have faced a lot of struggles, difficulties, right? So next time when we do, we will be kind of cautious. Okay, don't repeat that mistake again, right? We don't repeat the mistakes we did again. So it's based on the rewards and consequences, trial and error, right? Suppose there is a puppy. Okay, imagine you're training a puppy. Okay, a puppy doesn't know the rules at first. Okay, but you will give it feedback. Okay, suppose when it is sitting, when it sits, you say, "Hey, hey, good boy," and give him a biscuit or something, right? And then it is chewing your toe or maybe troubling you something. Then you say, "Hey, hey, no," and you take away the toy from that puppy, right? So it understands. Okay, next time I should not do this. Okay, and it repeats the good behavior. Over the time, the puppy learns which behavior will earn him reward and which behavior it doesn't, right? So it maximizes the good outcomes here, right? That is exactly what reinforcement learning is. So in machine learning also it works the same way. Like I just mentioned you the story of a puppy, agent here, right? You can see the agent is like a robot, a more like a, we used it in the self-driving car concept. It's the same. It interacts with this environment, okay, and if it takes action, it receives a reward. Or if it is no, if it's something negative, then it receives a penalty, right? So based on that feedback, it tries to adjust its actions. Okay, maximizing the long term reward, because everybody needs a reward, right? So if you need reward, definitely you have to behave well, or do good things. So that is what it is about. So this technology is used in the self driving cars, as I mentioned, and the go which I mentioned, which uh, defeated the chess champion, right? It is based on the same principle. And here there is no fixed data sets. Okay, model interacts with the environment automatically, how it learns. So now we learned about the types of machine learning. Let's go back to our feature engineering tech. Okay, so now the data we collected, we cleaned the data. Okay, we did the feature engineering, and we did the model training also using the three methods what we have. So now comes the testing part. Okay, now you have trained this doctor. Okay, you have fed him with lot of diagnoses. He's able to interpret it. Is able to do everything. But now comes the testing part, right? Because throughout in the college, if you have studied, and what's the point of not having a exam, right? There's no point. So that is where we are here. Now we are asking the doctor. We are handing over him a fresh file to the doctor and telling, "Hey, tell me what is your diagnosis? Tell me what is your take on this patient." Now the model is no different here. The same like the doctor. We give it a test data sets. Okay, the data he has never seen, and now we are measuring his outcomes, measuring how well it is generalizing, because we want to understand whether the doctor is simply just memorizing the old data, or maybe he's doing some cheating or something, or really he's able to find the patterns and give us the right outcome. So that is what this testing is about. Now comes the model evaluation. That is nothing but the scorecard. Now it is the examination is done. Now that comes the result part, the scorecard. Now we are grading the doctor. Okay, how well he did, whether he did it right, whether he did it kind of partially, or how. So here we are not looking at exactly at the accuracy. Okay, because in medicine, accuracy is not everything, because mostly right is not enough. We have to be 100% right in medicine, right? We cannot be 99% right and 1% wrong. So there are certain parameters, some measures using which we rate the model. Okay, for example, there is something called precision, like I mentioned. It is like saying when someone is sick, right? You go to a doctor and someone is sick. How often are you right? Is he really sick, or whether he's not so sick? Okay, that says the precision. And recall is about how truly, for example, along with me, there are four other patients who went to the doctor, out of which maybe only two people had diabetes, right? And the doctor, is he able to catch that only two people of the diabetic patients he's able to catch, or it's just like a testing or rating the model. Okay, same like how we are doing to the doctor, because here the metrics matters a lot, because if the precision is 100%, okay, the more precision it has, the more better the model is. And that is how that this model earns trust now, because here in the medicines, lives are impacted here, right? Because one wrong decision, one wrong diagnosis can ruin the patient's life, right? So now comes the hyperparameter tuning. So what is hyperparameter? It is more like a tweaking how the doctor thinks. Suppose the testing part is done, then results are also out. Now we saw that the doctor is becoming too cautious. He's not hesitating to give his right opinion, or sometimes he's like too aggressively giving his diagnosis. Then we see that, oh, we have to do some tweaking here. We have to go back to the doctor and tell him that you have to adjust the way you are doing the diagnosis here. So that is where we have certain parameters like learning rate, tree depth. These are some of the things using which you tune the model, right? That is what the hyperparameter tuning is about. It is like finding the sweet spot where the model just does right? Not too low or not too high. So now comes the model improvement. Okay, now we are done with all these things. We did engineering, we did testing, we did evaluation. Now you found that there could be there is a room of improvement for this model or for this doctor, maybe fixing the mistakes, I would say. Maybe the model struggles with certain edges. For example, if there is any elderly patient comes in, or some patients comes whom he has never treated before, right? He is not able to give proper diagnosis for them, that doctor. That is where we go back, analyze what went wrong, or maybe you have to improve the features or tweak certain things. So this is called model improvement. Okay, or here we are not doing anything from scratch, we are just tweaking him. Okay, tweaking the model uh, to make it kind of a uh, wherever there is a room for improvement, we are kind of tweaking him. Now your job doesn't end there. Okay, because sometimes in medicine or everywhere, staying relevant is very important, because medicine evolves, right? And so does the patient's patterns as well. So retraining is something something like a feeding in fresh. Suppose a doctor keeps learning, the model also has to keep learning, right? So it is something like feeding in fresh recent cases. For example, COVID-19. Doctors had not seen COVID-19 till 2019-20, right? They never even heard about it. Suppose there was a model which had no clue about COVID-19. So that COVID-19 data had to be fed to the model. COVID-19 features or the has to be fed to the model, right? Otherwise, it will not understand, right? This is what the retraining is about. So tomorrow, any new variant comes. Suppose COVID-19 variant again came in 2020, right? New variant. So that new variant also has to be fed to the model. So that is about retraining. So I think everybody is able to follow so far what we learned about the stages. I'll give a pause here. Okay, then fine. So everybody, I think have a good understanding about what are the stages of machine learning now, how the model life cycle goes, what is the process of training and retraining, everything. Now comes the point about. Okay, I think this one we covered.